Hey guys, welcome to tutorial number 8. Um, this tutorial is going to be mainly on classes, and we'll also have a bit of time at the end to talk about anything you guys want to talk about. Also, you guys just had test 2. I hope that went well. Some people were asking why there wasn't a test tutorial, and basically after going over the test, I found that there wasn't really anything that needed prior knowledge or clarification, so I didn't really bother. Um, and I think it went pretty well. Yeah, there was really just memoization and like memoization. There was yeah, there wasn't really like the huge overhead like you had with the Conway question from test 1. Uh yeah, the Conway question from test 1, you really needed to know how to maneuver a 2D game board. I'm not saying it was too easy. But it could have been harder, which either way, I think this is a good setup because you guys are going to do pretty well on the final exam. Hopefully. All right. Anyways, let's get started. Here we go. Okay. Oh wait, hold on. All right. So basically, what we're gonna do is in this tutorial, we're gonna create our own Pokemon spin-off class. So Pokemon seem like great idea for classes because you can instantiate them, number one, which is really important, and they can also have properties and functions. And hey, Albert, there might be exam prep. Once again, I'm just going to do the same thing I always do. I'm going to take a look at the test material and see if it justifies a preparation tutorial, and if it does, then it'll be there. Okay. Yeah. So we're gonna have a Sakamon. Basically, the Pokemon Sakamon, whatever, is gonna have all of these properties, and it's gonna have all of these functions. And that's the first thing we're gonna do. And then after that, we're going to make another class that inherits from the class we just made. So it's basically a more specific version of Sakamon. And all it's going to have is a nickname property and a set nickname function. And this is in addition to all the properties that we're inheriting, right? Because when you inherit from a class, you get all the properties and functions from the parent class that you inherit from. So we can get started. You guys have also been working on classes very recently, especially on question 2, or was it question 1? The stuff with vectors, whatever that was, from your current assignment. So we can start. We're gonna have a class Sakamon, and we can make our initialization function, which is gonna take self. So self for sure, and then we can take a look at what other properties we need, because our init function has to assign all of those properties to the instance of our object. So let me show you how that would work. So first we pass in self, obviously, and we're also going to pass in whatever the name is for the input, as well as type. But as you can see here, type is actually a Python keyword, and you, like, for good practice, you generally don't want to use Python keywords as variables, because then you're overwriting them and things can get messy. So we'll just call it TYP without the E. We'll have level. We can have a max HP. And then here it says our current HP is going to be defaulted to the max HP, which basically means when someone creates an instance of this Sakamon, if they don't specify a current HP, if they leave that out, then it should by default be the max HP. So we can do that by using default arguments or optional arguments in Python, which basically means we set it to something. So we can do that. And status, there's either a status of OK or depressed, and by default, they're going to be OK. So there we go. And we can start writing our thing. So we can basically just assign, we can assign all of the inputs to properties of our instance. So self.name is a property that we're making for our for each Sockemon, and it's going to be assigned the value of whatever is passed in as name. So it'll be self.name equals name, and you'll basically have the exact same format for all of these, right? So self.type equals type, self.level. yeah. Self.max HP equals max HP. We'll leave the default to OK for now for the status. Equals max HP. And okay, here's the thing, right? Is that if you look over here, cur HP equals max HP, that would actually not compile. If you try to run this, right, which I just did, you'll notice that we get a name error where max HP is not defined in this line right here. Because we're trying to assign current HP to max HP, even though max HP isn't even a thing yet, right? Because it's part of the arguments. So it hasn't even been passed in when we try and use it. Which is why we have to do a little workaround. There's no other way to really do this in Python, but we can basically just default it to none, and then we can say if cur HP is equal to none, then we can set self.curHP to max HP. Or yeah, max HP. Else, we can set it to cur HP, right? So that's basically the idea. Or wait, hold on. By default, yeah, okay, this seems right. So if they leave cur HP out, then it'll default to none, and this will be true, which means we'll set it to the max HP. Otherwise, if they actually do put an input for a current HP, then it won't be none, it'll be a number, and so we'll set the instance property, current HP, to whatever that input is, cur HP. So that seems to be, oh, we forgot the status. We forgot the status. We could just put this down here. Or actually, let's put it up there just to be clean. Self.status equals status. And that's really it for our init function. If we run it, we see it compiles fine now because of our little fix here. So I'll actually leave a note of that. Have to default cur HP to some arbitrary value other than max HP to avoid name error. All right, and so let's go back to the top. We just finished assigning all these properties in our init function. Now we can take a look at the other functions we need to fulfill, which we have attack, which has a damage multiplier function, a level up function, a heal function, and a built-in Python string magic method function. So we can start with attack, and attack's going to take in self, and it's also going to take in a few other things. Not a few other things, just one thing. It'll take in the other Sockemon that is trying to attack. So we can call that other, and this other will refer to the other Pokemon. And so let me give you guys some of the, hopefully this format's okay, but I'll go back up here. Maybe I'll do it here. Okay. Hopefully that's okay. But basically, there are a few rules to what our attack's going to do. It'll take in self and another monster, and it'll reduce the target's hit points according to the following rule. So it'll reduce others' hit points. First, we calculate a base damage, which is equal to the attacking monster's level, the defending monster's level. We subtract those from each other, and then we add 15. And we have another rule, is that if the base damage for an attack is less than or equal to 0, then obviously they don't take damage. And having a negative base damage does not mean that they gain health. It just means that they won't take damage according to this rule. And then we're going to use a function, modify damage, but in this case, I'm calling it damage multiplier. So let's replace that. And it doesn't take in base damage. It just takes in the attacking type, the defending type, and it calculates what the multiplier is going to be depending on the types, right? Because as you know, like some types are effective against other types are not effective against certain types. And then the last rule for attacking here, actually, never mind, not the last rule, but one of the rules is the monsters are conscious of each other's emotional state. So an okay monster will never attack a depressed monster. And another rule is a depressed monster will not attack, so it just does 0 damage. And the last rule here is if an attack defeats the defending monster, so brings its health down to at least 0, then that monster, I'll clarify here, the defending monster, not the attacking monster, becomes depressed, and the attacking monster will gain a level according to this level up function. So that's a lot to take in, but it won't be too bad. We can go ahead and do that. So let's not worry about the damage multiplier for now, and let's take care of that later. So first we should probably calculate the base damage. So we can say, actually let me just type in the whole name. Base damage is going to equal to self.level, right? The attacking level minus the defending level plus 15. So that's literally already taking care of the base damage. And so now we should probably actually do the attack, right? So we're going to be lowering the current HP of other based on a few conditions, right? First, we have to make sure that the base damage is over 0. And we have to make sure that the Pokemon that we're trying to attack isn't depressed. Because as you noticed, where is it? Right. They're conscious of each other's emotional state. So we will never attack a depressed monster. So if the other monster is depressed, we won't attack it. So other.status is not equal to depressed. Like, to be honest, there's only two options. So by saying other status is not equal to depressed, if it's not equal to depressed, then it's equal to okay. But we'll just leave it like this. And obviously we also have to make sure that our status is okay, because another rule is that if the attacking monster is depressed, where does it say that? It says it somewhere. Right. If a depressed monster will not attack, so it does 0 damage. So it just won't attack. So we can add that too. So we can say self.status is not equal to depressed again. So yeah, we basically have to make sure that both the attacking and the defending monster are not depressed. And if that's true, then we can lower the defending monster's current HP, which is basically that's what we're doing when we attack the defending monster, by the base damage multiplied by the damage multiplier, right? That's the whole point of having a multiplier, is that it modifies the base damage. So I'm sure you guys know that this minus equals just means like it's the same as plus equals, but with the minus, it's just shorthand for subtracting itself. Yeah, we're not gonna worry too much about encapsulation, but we'll get to that. We will get to that. And there's a small note I want to make. Our second Pokemon that we're gonna make, which has a set nickname function, delves into a little bit of what encapsulation is and how we can use it. Anyways, so we need to pass into the damage multiplier the two types, right? It takes in the attacking type and the defending type. And that's it. So what else do we have to do? Right, okay, if the defending monster's HP gets lowered to 0 or below, then we have to take care of that. So after this attack takes place, if it does, we can check the HP of the defending monster. So we can say if other.curHP is less than or equal to 0, then what's going to happen? The defending monster is going to become depressed. So other.status is going to be set to depressed. And what is it? The attacking monster gains a level. So we haven't actually written the level up function yet, but we know that the attacking monster is going to gain a level. So we could just run the level up function. And we will define the level up function next. I'm pretty sure that's it for attack. That takes care of everything that was laid out here. So we can do level up next. And let me get you guys the description for level up. So it takes no argument other than itself, and it has the following effects. The monster's max HP is increased by 5%, rounded down. The monster is healed back up to full, and its status is reset to OK. And the monster's level, of course, is increased by 1. That's the whole point. So we can define our level up function. And I'm pretty sure it's only going to take self because it doesn't need anything else yet. And what's going to happen? Well, first we need to take care of the max HP. So self.max HP. Once again, I'm using these shorthands. So times equals is exactly what you think it is. It's basically equivalent to saying this. 1.05, right? If we multiply it by 1.05, then it's increasing by 5%. But we need to make sure to floor that. But we also don't need to use the floor function for math. We can instead just use the built-in int function, which by default, as you know, is just going to chop off the decimal places. So that's the same function as flooring in this case. What else do we got to do? We got to heal the monster up to full health and reset its status. So heal and status is equal to OK. And what else do we got to do? Of course, we got to increase the level by 1. So we'll say plus equals 1. That looks good. So the next thing we want to do is we want to code the heal function because we're using that in our level up. So I'll try and get you the heal. Here's heal. Takes no arguments other than self and restores the monster to full HP. And also cures depression. This is actually interesting. If it cures depression, it means that your status is reset to OK. But if you take a look here, we actually healed and we set status to OK. So this line right here is completely redundant because if our heal function is already going to set our status to OK, then we don't have to do that a second time. So we can take this line out and we can code our heal function. I keep forgetting what they do. Yeah, okay, it just restores the monster to full HP. So the cure HP is going to be set to the max HP, right? And the status is going to be set to OK, because we're curing depression. It's that easy. What else do we have to do? We have to do the string. So there's also a description for that. Here it is. Okay, the coloring is kind of weird, but when we turn this function into when we try to display this Sakamon as a string, the format is going to be as shown here. So you're going to have level, with the attack method, if a Sakamon attacks a depressed Pokemon who's already at 0 HP, I think they'll level up. That's absolutely right, because yeah. So if the other Pokemon is already at 0 HP and you try to attack them again, they level up. Let's leave it like this for now, and we can revisit it at the end and make a fix. But yeah, for now we can just make it so that Pokemons can't really attack other Pokemons that have yeah, they can't really attack other Pokemons that have already died. Yeah, we'll fix that later on. But let's just generate a working version of the class just in case we don't end up having time, but I'm sure we will. So we have to write the string function. And this is going to be a long one because we're basically stringing together all of these different things, and we want it to look like this, right? This is what we want the output to be for an example string. So it's going to be something like level with a space at the end plus self.level. Okay, here's a cool thing. So you guys all know that you can concatenate strings together and turn them into like one string as an output, right? Thing is, with a string like this, that's easily doable and it's very easy, but it can get pretty long and convoluted. So there's actually a much easier way to do it, is that you can use Python's built-in format function. And I'll show you guys how that works. So basically, you just write the whole string in, and everywhere that you want to put in like a variable or function output, you can actually just put in these little squigglies. And then later on, you can say what those squigglies mean. So let's actually just copy over this example, and I'll show you guys what that means. So obviously this level thing, this level part is going to be a literal every time. It's always going to say level. But this 17 depends on the actual Sakamon's level. So we'll put in squiggly brackets, and this is always going to be the name. So we'll put in squiggly brackets there. This will be the current HP, right? It's current HP out of maximum HP. So we'll do that here. And this is going to be max HP. So we do the same thing. So now we have all of these squigglies where there are supposed to be variables, right? So now what we can do is we can dot format the string, and we can pass in what we want each squiggly to represent. And it makes it a lot easier. So we can just pass in self.level, self.name, self.curehp, and self.max HP. And it will recognize that this first argument belongs to the first squiggly, the first pair, right? The second one belongs to the second, so on and so forth. And that's how it figures out what to put in each bracket. So that's basically it. We've actually pretty much got it done. We do need to code our damage multiplier because we actually haven't written that function yet. So let's do that really quick. It's going to be called damage multiplier. It's going to take in an attacking type. and a defending type. So let's see. Let's actually define what the types are going to be. Right? Type can be, we're going to say water, fire, and grass. Just to keep it simple, these are the only types that we're going to implement. So, okay, if the attacking type and the defending type are the same type, then we're going to make it so that the damage multiplier doesn't actually do anything. So it doesn't decrease or increase the base damage, which means the damage multiplier will be 1, because if you multiply the base damage by 1, it won't change. So if attacking type is equal to defending type, then return 1. Otherwise, if, all right, let's see here. This is going to be a long one because we're going to do each pairing of strong, like effective attacks. So basically, water on fire is effective, right? Water is effective against fire. Fire is effective against grass. Grass is effective against water. So we're going to code for all those conditions. So if attacking type is equal to, let's do water first, and defending type is equal to fire, or right, we're gonna have all these ors. And the thing is, it's gonna be very long. You can use backslashes in Python. You might have seen this on your assignments to separate lines. So if Python sees these backslashes, it knows that you're trying to put this all in one line. So it'll recognize that and it won't screw up any of your interpretation here. So water beats fire, fire beats grass, and grass beats water. So if any of these conditions are true, what are we going to do? We are going to return 2 because we want to double the damage. And then else, because if they're not the same type and it's not a effective attack, then it's going to be an ineffective attack. So we'll return 0.5. And that's basically it. This should take care of every case for the attacking and defending type pairs. So let's try and run this cell. Okay, it runs just fine, no errors. Let's see. What else should we do? I guess let's try and instantiate a couple of these Pokemon, or Sakamon, right? We'll say Basil, right, equals Sakamon, and we'll pass in every argument that it needs. So it needs a name, a type, a level, and a max HP. And optionally, you can specify a initial current HP and an initial status, but we're not going to do that. So we're just going to get these ones, right? So for name, we're going to say, actually, yeah, let's not call this Basil. Let's call it my Sakamon, or let's call it, what should we call it? Call it Saki. Basil, he's going to be fire, and level is going to be like 42, level 42, and max HP is going to be not a string, it's going to be 99. 99 max. Actually, that's weird. We'll do 100. Okay. So let's try running this cell, and we see that it also runs just fine. So we have one Sakamon, but that's not really good because in order to use our attack function, we need to have another Sakamon that we can attack. Would a fix be moving the second if statement? Second if statement inside the previous if statement. Let's take a look. The thing is that, oh, Wait. Yeah. I think so. Because if they die, then their status gets set to depressed, which means this won't run. Very cool. Very cool. Thank you. Can I get a feature? No, not yet. Soon. There will be time for features. So we should make. Actually, oh, okay. Yeah, you can get a feature. Jared's gonna be called Jared, and he's gonna be a grass Pokemon, and he's gonna be like level 12 and max HP of like 4. Okay, maybe not 4. We'll do like 120. Okay, so now we've got 2 Sakamon all prepped up, and we can run an attack. So let's first try and print both of our Pokemons. All right, there we go. So we never specified a current HP and an initial current HP. So they obviously both default to their max HP. And even though you can't see it, their status should be okay because we didn't set them to depressed. Okay, Jerry's about to get murked. Because what we're going to do is we're going to call the attack function. We're going to call the attack function that belongs to Saki. And we're going to pass in Jared, which is the defending Pokemon. So Saki is going to attack Jared like this. And now, if we print out Saki attacked Jared, if we print out their values again, we should see a change, hopefully. But instead we get a name error because damage multiplier was never defined. Even though it was. We might have forgotten to run the cell again after we've made this function. So let's give it a quick run. And then, oh, might have messed up the, oh yeah, oops. There we go. Let's try this again. Runs fine. But we still get a name error. I think it might need self. I think since it's part of the since this function is part of the class, it needs to have a self argument, maybe. So we'll run it again. And we'll try this again. This isn't good. What's going on? Okay, it's not working. I really don't know what it could be. I don't think this has to be. Oh, true. Okay, guys. Thank you, Jared. Jared just saved us. So since the damage multiplier function is part of the class, you need to actually call it as a class function. So alternatively, we could just put this outside of the class. I actually think that's probably better. And then not have to call it from the self object here. But this will work fine, I think. So if we rerun the function again, we rerun this cell. Oh, shoot. Yeah, Jared kind of got destroyed. All right. So let's even it out a bit. Is that right? Yeah, I think that is right. self level minus other level plus 15. So it would be 69 minus 12, which is 57 plus 15, which puts us back up to like 72 times 2, which is 144. So it was times 2 because it was a strong attack. It was fire against grass. So 144 damage brought him from 120 damage to negative 24, which is insane. So let's even out the battle. And what we can do again here is we can actually put this in a loop. We can loop the attacks. And we can also make Jared fight back, because that's probably only fair, right? And so let's put this in a for loop. We'll say all right, I'm gonna set it to 120. I'm actually gonna give myself a small level advantage, and then I'll make myself water. And I'll say while Jared dot while Jared dot current HP is greater than 0 and Saki. Okay, I guess we could do that. And we can do this. All right, let's give this a go. Okay. Okay, all right, this is cool. So what happened was, I started off at level 15. Oh, oops. Forgot to have the print statement. Well, basically I got smoked. We'll see why I got smoked. Yes, we both started off at 120 HP, and then we attacked each other, and he did a lot more damage. He did 24 damage. I only did 9, because of the effectiveness of the attacks, and the attacks just continued. They continued until actually he leveled up because he killed me. So he went back up to full HP, but he was at 84. So it was close. I almost got him. Anyways, that's pretty cool. We successfully emulated a little Pokemon game and we ran some attacks. What we can do now is we can go ahead and make our small improvement, which is going to be another class that inherits from Sakamon. So let's actually restart and clear. Let's save. Let's restart and clear the output. Okay. And we'll run this cell again. And we're going to add another cell above it. And so this class is going to be called named Sakamon, I think. And it's going to inherit from Sakamon. So as you guys know, we put the name of whatever class we're inheriting from, aka the parent class, as an argument when we create a class. And we can make our init function. And that's going to take in basically the exact same things as our original parent class, except it's also going to take in a nickname. So I think we can put that nickname right here. That makes sense. We'll have the name, the nickname, and then we follow it up with everything else. So this is what we're going to do. We need to basically run this very same constructor in our child class. And the way we can do that is by calling the parent instructor. So since we're receiving Sakamon as an argument here, we can actually use Sakamon and call its init function. There's another way to do this using a Python command called super. If you want, you can look up super later on, but it's very similar. You basically you'd put super in here instead of Sockemon, and it would basically automatically find what the parent class is. But it would work the same. For now, we're just going to use Sockemon, and we're going to call this init function. And it is going to have like basically all of the same stuff. So it's going to have self, name. The Sockemon constructor doesn't take a nickname, so we don't pass it in. But it does take the type, the level. You can just copy this. All this other stuff. So there, we've successfully run the constructor, and this constructor will store the result in our own self instance. So we're basically going to get all the same stuff that would have been instantiated in our parent class, instantiated in our child class, which is great. That's what that line does. And then, of course, additionally, we have this nickname that we're taking in. So we can, just like always, set the input to the instance's variable, its property, which is nickname, like that. And so that takes care of the nickname property. We need a set nickname function for if we want to reset the nickname function. That's very simple. We can say set nickname, and it takes in a new nickname. Can't type. That's very easy. All it's going to do is just reassign the value that's associated with the nickname variable. Easy. So that takes care of our named Sockemon class. If we add another cell below here to try and run this, we can basically call them the same way here. We call it like Nick, because it's going to be a Pokemon with a nickname. Let's call it like Nicholas. And keep in mind that the nickname argument comes right after the name argument and before the type argument. So we're going to squeeze in another argument here, which is going to be its nickname. And his nickname will be Nick. Pretty reasonable. And boom, it runs fine. So now, if we try and print out Nick, yeah, sure, let's do that. We have, oh no, ooh, I forgot the, well, something's very wrong here. Something is very wrong here. Oh, we don't need this. Sorry. When we pass in the oh, never mind, that still doesn't fix it. No. Yeah, but when we pass in these two variables, it should be defaulted. I'm not sure why we're doing 120. How does it go? Name, nickname, type, level, max HP. But if it's equal to none, it should This is tricky. We're not missing anything, are we? Name, nickname, type, level, oh, well, we still need cure HP status. That doesn't do it. Okay. 12015? Well, that's not exactly. We want it to default to the max HP. Your current HP is set to 120 and your max is 15. How? Wait. This should be max HP. Oh, oops. Wait, no, hold up. You're running this into Sockemon. The type of the Sockemon is Nick. Oh shoot, is it? 1, 2. 1, 2. But see, it should like when this is passed in. Should we look at the string? Name, current HP, max HP. Level water and type should read Nick. Where is that? Level water. Oh shoot, true. I'm actually really confused. I thought this would work. Okay, so we have type here, and it's being passed into this. I don't think it's going to change anything. Yeah, that does not change anything. Oh, geez, guys. Okay, oops. That's stupid. Thank you, Adrian. We forgot to make it a named Sockemon, and that's dumb. That's really dumb. Okay, yes, thanks. We were trying to make a nicknamed one, and we didn't even make it a nicknamed one, which is dumb. The string function still works fine. So here we go, and we can print it. Let's override the string function. So overriding basically means when a function is already defined in a certain context, and you're overriding that function. So we're saying we don't want to use the one that already exists. Instead, we want to define a new one. So string already exists for named Sockemon because it inherits it from Sockemon, but we're going to make our own, and it's going to be very similar. So we can just copy and paste it. But we're basically going to say AKA, and then we're going to have another one. So here we're going to add self.nickname. We run that, Ta-da! Okay, cool. And we can test out our set nickname function, which basically sets a nickname. We'll call it Nikki. And we can try printing Nick again. And the nickname changes successfully. So that's the idea. The whole point of this was to kind of show you guys what can be done with classes and how it's separated into properties and functions. And also dive a bit into inheritance. I can show you guys that if we replace this with super, which is what I was talking about earlier, we call the super function, and this returns the parent class, which is obviously Sakuman here. If we run that, actually it does not work. I lied. Don't do that. Oh, okay, wait, sorry. So maybe, it might still work. Let's just try removing self, maybe? Okay, cool. Yeah, super works here. You just don't have to pass in self. And not pass in self as an argument. Yeah, no, it's different in Java than to Python. Here you actually call super, and you still have to call the constructor manually using the init here. Yeah, so let's replace this with Sakuman again, and keep the self, and I'll leave that note there. But yeah, that about covers it. Does anybody have any questions? This is really all the content that we have for this tutorial. If anyone has any questions about classes or anything we did today, feel free to ask. I'm blushing, Jared. Thank you, sir. I'll upload this notebook to Avenue again, and you guys can download it and play around with it if you want. You can try adding your own functions or your own properties. You can do anything. You could make your own class and then inherit from some of the existing classes. It's really a big playground for you to mess around with. All right, if there are no questions, then that about wraps it up. I'll give it like another minute or so. I don't know if someone's typing up like a monster question or if just rare, or if this is just like easy to understand, because it's pretty intuitive, and you guys have already had time to play around with classes in your current assignment, which is good. Also, assignment 6, which is your current assignment as of after midnight tonight, is your last assignment. No more assignments after that. So it's the final stretch, guys. Just one more assignment and you'll be done. And you'll smack the final exam. And boom, 12s for everybody. It'll be great. So you're very close. All right. Looks like no questions. Thanks everyone for coming. And yeah, I will see you guys on Wednesday for the next tutorial. See you guys.